So I'm assuming everyone can hear me on a scale of 5. 5 is perfectly readable. Very warm welcome, students. Very good evening, good afternoon, good night in some areas in the poles, North Pole. Sometimes always night, always morning. You learn all that in navigation, a little bit of not complete areas about the Arctic Circle and everything. We have full strength, I guess. I think a couple of students here and there up there, but very happy to see Gulshan. See if anybody else is joining. In the meantime, all that you have done in the last class. See if you have any questions. If you have any other questions in your mind that you would like to put across, feel free to share. And let's see if we can resolve them now, or we can prepare to resolve them ahead. But let's just give 5 minutes, settle down, go through our books, notes, last class, and see if we have any questions. Feeling confident with 1/60 and its applications? Understood all the different parameters. So this is for students who were there in the last live. We've done so much. Do you have any questions with respect to that? Think and talk to me. Where is Chaitanya? Vishnupriya is here. Vishnupriya, very warm welcome. Good evening. I hope you can hear me 5 on a scale of 5. See if you have any doubts. Nukul, Gulshan. Sandeep, you parallelly work on what the task is at hand. In the meantime, wherever we have dead air or gap simultaneously, while everyone is revising, thinking, and we're waiting for Chaitanya to join.
All right, sir.
Yeah. I would want to see like how much you have gathered. I've shared the syllabus with you. Check, and as per that, you can do it. Students, individually, if you don't have the syllabus, this is for everyone. Let me know. I'll share it with you. Do not get intimidated by it. Most of it you would see if you carefully read, you would have covered. The things that you think you don't know or you have not covered, share them with me. Anytime that you can, within 2 to 3 to 4 days at max, by 15th of May or something. If I have that list from your side also, and make it a calculated list. Don't just put the entire syllabus there. Because you have studied so much already, just put on the critical areas where you think are challenging for you, not the ones where you have not revised. So we're not talking about revision pointers here. We're talking about topics or concepts which you have no idea about. So do make it in a piece of paper like general navigation, radio navigation instruments. In the past, if you have made it in the past, update it and reshare. And write your name and everything properly. And that should be your final checklist. Or those who have access to printouts, you can just print out the syllabus and make that syllabus as a checklist. Simple as that. How much is done, how much is yet to be done. And in that checklist, you can just put your page numbers of the textbooks and textbook references as to know ye kahan milega, ye kahan milega, ye kahan milega. Don't have to do everything that is there in the syllabus, to be honest. A few things can be omitted. But then just study and make a list, and I'll tell you what's on priority and what's not on priority. Feel free to share as and when you can, especially if you are planning to give exams in the coming session, like in a few days' time, sometime, couple of weeks, 3, 4 maybe. Okay, so Chaitanya is here. Very good evening, Chaitanya. Very warm welcome. I hope everybody can hear me on a scale of 5. Everyone, can we get started? Okay. I can see the reactions, and if you try a couple of reactions, see if you're getting it. Yeah. So, okay. Yes, this is like, yes, I'm getting it. This means I have a question or doubt or I want to share something. That's it. And rest emojis, you can use. Nukul, go ahead. What's your doubt? And Gulshan, no response from you. What's happening? You are on the hit list for responses, right? So you should be the first one to respond. What's happening, Gulshan? Are you there? Are you not there? Nukul, please go ahead.
So earlier class, we saw a question that we need to find out rate of descent feet per nautical mile. So we find out glide slope and we multiply by 100. So that formula is Z into 100. Is that formula or
It's
we
a
take?
direct formula. It's a direct formula to find rate of descent per nautical mile. It is a direct formula. So to find rate of descent per nautical mile, you don't have to do reductions of speed and reducing. The formula is pretty simple. Glide slope angle into 100 gives you nautical miles, rate of descent per nautical mile. Simple.
Sir.
What we learned was in CX3, there is a way to find it indirectly. AOC, AOD. Remember. So that can be directly found out there also, if you don't know the formula. But the formula is also easy. Any doubts?
Yes, sir.
Chaitanya, any doubts from what we have done so far? Are we 100% thorough? Everyone, this is for
Yes, sir.
everyone.
No
Think
doubts.
and ask. Sandeep, if you have any doubts with respect to 1/60 on your mind, feel free to share right now. Otherwise, you can wait whenever you have the doubt out. Anything on the top of your head, feel free to share.
Sure, sir, I'll wait. Right now, I don't have anything.
Good, good. No problem. How many of y'all have covered basics of gyro? How many of y'all not covered basics of gyro? As in, you don't know what is gyroscopic properties called rigidity, and you don't know what is gyroscopic property called precession. Anything. If you have never studied, just drop me a wait. Just drop me a message on the Zoom chat. I'm just sending a hi. You can reply to that. Okay. Anyone who doesn't know. Basic introduction is fine. So Gulshan, Prerit, no doubts there. Karishma, very good. Muskan, Vishnupriya. So everybody knows. If I have to ask about wonder, do you think you'll be able to talk about wonder? Good. Very good. Let those concepts revolve in your mind right now. Just revolve. You don't have to go through notes. If you have access to your notes, I don't mind you going and giving it a quick revision. I'll tell you why. Nukul, I want to ask you a couple of questions on these properties. Gulshan, I want to ask you a couple of questions on these properties. Muskan, Vishnupriya, Jyotsna. What are the properties? There's rigidity, there's precession, and there's formula for these two. If you're thinking you don't know the formula, then the formula is simple. Rigidity is directly proportional to this and inversely proportional to this. Precession is directly or inversely proportional to this. And what are the factors involved in rigidity and precession? There are three elements: rotor RPM, force of torque, the 90-degree delay or the variation in the direction in which the precession occurs, axis of rotation of a gyro. What is a gyro? In short, a gyro is an instrument that will give me a stable reference. What is the most common example that we see in our daily lives of gyro? When I'm out on the street, I see people riding bicycles and motorbikes and scooties. Motorbikes, two-wheelers that I see, and bicycles, like cycles, that I see every day are exhibiting the property of rigidity. And that is the reason thousands and thousands of people in every area travel to work day in and day out. We are using the gyroscopic properties to help us in our daily lives. We are not strangers. As children, we have toys, spinning tops, gives us gyroscopic properties. There are cameras that are stable, gimbal, both ways are allowed for pronunciation. You can say gimbal also, you can say gimbal also. Okay. Spelling remains the same. Gimbal rings, gyroscope, gyroscope. You can choose whatever pronunciation you want. In aviation, we use gyroscopes. Gyroscopes could be any rotor spinning at an RPM that is so fast that the axis of rotation of the gyro, thus the axle on which the wheels are, that is also the axis of rotation of the wheels. Similar to that, there is an invisible axis. Earth also has gyroscopic properties. The tilt in the Earth's axis is generally referred due to the precession of the Earth's rotation about its own axis. But that is something that is not very highly referred to in our training. Anything rotating at a high RPM tends to maintain its orientation with respect to its axis of rotation unless it is disturbed by an external force. The external force will deviate the orientation of the axis. Now, if this is an axis of anything, and if I'm pushing it from down, the axis will go up. Simple. If it is here, if I put it down, the axis will go down. If I have a rotor on it, the rotor will also move along with that up or down. Precession does the same thing, but in a direction that is 90 degrees ahead in the direction of rotation. That 90 degree is the main element for you to know. Why? Because by the time the force of the torque is applied, the force, and by the time the reaction of the force happens, the RPM is so fast that the point of torque and the reaction, they are 90 degree ahead of each other in the direction of rotation. So the axis goes away from its original alignment. This axis going away from its original alignment is against the property that gyroscope exhibits. And that property is to give a stable reference or a datum. That stable reference or a datum is achieved by the characteristic of gyro, which is known as rigidity. So if I have precession, I have compromised my rigidity. If I don't have precession, I have high rigidity. What gives me this rigidity? The circumference of the rotor, RPM of the rotor, mass of the rotor. How can I drive this rotor? Through air, through suction, through electrical motors. Suction basically is created first. And because of the suction created, air is allowed to flow. Wherever there is suction, air will flow. And then there are vanes on the drum of the rotor where the air hits, just like a turbine of a jet engine, just like a propeller, I would say, any which ways. A free windmill also, if you have used, it has some vanes. So we need this stable reference with respect to what now? What are the applications of gyroscopic instruments? Gyroscope has precession, has errors. Those errors are against rigidity. So if we have any instrument that has to give us stable reference, that instrument will also have precession. And in that instrument, we need mechanism to avoid that precession. Why would precession happen? Rigidity has one loophole. Rigidity will be there with you as long as you are not troubling that particular person, the particular gyro, and you are giving it the drive it needs. If you're giving it the drive, it will keep having rigidity. But if you're changing its orientation in space anywhere, gyro is supposed to stay the same. Let's say this is the plane of straight and level flight. This is the gyro axis, one of the gyro axis, vertical axis this is. So if my plane turns right or left, bank right, bank left, the gyro is required to remain straight. If I go like this, gyro is required to remain straight. If I go like this, gyro is required to remain straight. But because of these motions and because of the mechanism of the gyro, certain gyros will get displaced, as in get precession. Now, displacement gyros are a little different. They are also measuring displacement only and giving us certain measurements like DGI. There are certain gyros which give us different readings. So my gyro instrument will have certain errors because of the mechanisms involved. And I need to be able to know those errors, fix those errors. Then I get rigidity. Second thing about gyros, you need to know that when the aircraft is not live, everything is dormant. Batteries are there, but they are not supplying electricity to any part of the aircraft. And engines are also not on. When you are turning on the engines, after that, you get total power supply to the aircraft. Before turning off the engines, you get partial power supply, which will help you turn on the engines. It's like that. So gyros and all will require rotation to come into effect. Who will give them the rotation? The rotation will come only after the engines have been started, and it takes some time. The rotations are required for the gyro axis to come to its original designed application in the aircraft. It is supposed to be like this, it will come to this orientation. If it is supposed to be like this, it will come to this orientation, whatever the orientations are. But for that, we need RPM. For that RPM, we need time, we need energy. So there are terms used for these things. So in basic idea, whatever gyro instruments you will have, these basic points will guide all gyros. So all you have to do is understand all these basic points, which points are related to which gyro and what are the applications or what is the impact on the other things. Now, understanding and listening to something in an easy way without technical pointers is the first step to master something called gyro. Second step is to fill in the basic description with technical jargons and then memorize. Now you know the simple aspect how to understand what the instruments are going through. All you need to know is, okay, what happens when? What are the problems? You might be wondering, okay, gyro, where does gyro exactly fall? Gyro falls under instruments. But when we think about instruments, we only think about altimeter, ASI, VSI. Mach meter is not to be done in depth, but couple of speeds with respect to Mach meter are important. So I would say, why not just read up the theory also? These are air data instruments. Instruments that get data from the air. Instruments that give data about the air outside. Altimeter is a pressure sensing device. It measures pressure, but gives us altitude. Airspeed indicator is also a pressure measuring device, but then it's a differential pressure measuring device. Dynamic pressure, total pressure. VSI is again playing with pressure with a calibrated leak. Mach meter again playing with pressure, but giving relationships in Mach number instead of this. The next set of instruments are the instruments that get information with the help of gyros or that work on the principle of gyro. They are gyroscopic instruments and they are a part of your primary instruments. If you remember the first lecture of instruments, what are the basic 6 or basic T instruments? How many of them are gyros? 3 of them are gyros minimum. Directional gyro, artificial horizon, turn and slip indicator. Out of the 3, 2 might not be there, but 2 might definitely be there in a basic 4T type configuration. If you are someone who has attended all those lectures and unable to recall, it's about time, revise. So one of the most important primary instruments that works on the principle of gyro is something that we are going to talk about. And we are going to discuss points that are related to exam level questions. Whatever you're going to do right now will be very much in need, very much needed for you to be able to mark correct answers with respect to questions from gyroscopic instruments, or as of today is concerned, artificial horizon. I'll be walking you through this with the help of the whiteboard, flowchart, notes, and everything. I'll show you a couple of pictures also. You have to understand things from your CPL perspective, not ATPL perspective. So I'll be respecting that, and I'll be training you with respect to that focus. So please have 100% focus, because I'm anyway teaching you less compared to more. If I would have taught you from ATPL level, even if you have missed 20-30% in class, you would have safely fallen into the category of finishing CPL. Okay. So certain mechanisms, how they are coming in place, the in-depth is not to be learned, but the impact of that in-depth is to be learned, which will be discussed. You might have a couple of questions, ये कैसे होता है? I'll be like, wait for it. अभी क्या हो रहा है वो कर लो, क्यों हो रहा है वो कर लो, वो अंदर क्या हो रहा है बाद में करना उसको. So understand there might be two levels of understanding most of the instruments. Some instruments that you will be learning, not just gyro, in general, especially remote reading magnetic compass, something to do with the DGI, the other one DGI, like the ones that are electronic gyros. There, what is the electronic or digital mechanism that is fulfilling the properties of a mechanical gyro are required to be studied a little in depth. But apart from that, you are very, like, not needed to be stressed about too much. I don't want you all to not have focus and miss on the things and then be confused for the rest of your lives. That is very important. I hope the expectation is set. I'm liking the pointers. Properties of gyro are rigidity and precision, but don't know about their specifications. Students, you have to study. Please go through the lectures and study and get done with it. Lecture numbers are there. Everything is there. If you can find, great. If you cannot find, show me where you are stuck and I'll show you where to do it from. Please study. It is very well taught. I'm the person who's taught and you are the person who's learning. So please attend and finish that. It is very important. Understand, I'm just talking about other students, everyone who's been studying. We have covered fundamentals of everything. I think only radar fundamentals are pending. That's it. Fundamentals are covered for everything else. You just need to do the final level 4 level training. So it's not difficult. If your fundamental of gyro are not done properly, there's a session, 2-3 lectures at max. Attend and you'll be very happy in your life. You'll be like, wow, mera ho gaya. Remember, okay? So please, if you have not done that, then you're right to panic, saying mera bahut bacha hai. But aapka utna ho gaya, so you don't need to panic. Or after that, you just need a flowchart. So please be mindful of it and finish what's pending. And rigidity is directly proportional to moment of inertia and rotor RPM. Moment of inertia is dependent upon two parameters, sub. I can recall the entire session easily. When was it? But it's all coming back to me. Why? Because I had focus while teaching. If you keep the same focus while learning, you have nothing to worry about. Precession is directly proportional to torque and inversely proportional to rigidity. Okay. Good. Let what I said revolve in your mind and let me know if you have any questions. I'm sharing the screen. A simple search on the web also shows you what these are, artificial horizons. And why do we call it artificial horizon? Okay, I'll just show you. You must have seen it. I'll just show you random pictures, and then we'll start with important pointers, key points, errors, and what are the exam specific pointers that we need to remember. See, a basic web search gives me this. This is a type of gyro horizon, artificial horizon. This is a type of artificial horizon. You see, there is a knob on the right saying pull to cage. On the right, there is a knob pull to cage. There is blue, there is brown, there are numbers and lines. On the periphery of the instrument also, there are certain markings. Let's see more. This shows you the backside of the instrument also. You see there's a big housing like your computers have. This looks like an electric gyro to me. Not sure. It could be a power-driven gyro also. Looks like an electric gyro. So there will be two types of gyros, electric and air-driven or pneumatic. This is something that is more advanced version of a gyro, where the sensing instrument is a little different, where information is not given to you directly in the instrument, but information is fed to a common instrument like a digital display. So on this, you have just one paragraph to learn. What you need to learn for CPL are the ones that are conventional, pneumatic and air-driven. Pneumatic are the ones that you're required to study more in depth for CPL. This is again one of the most classic types of artificial horizon. You see, so many things are there, flags are there. DHGA is also written there. Glide angle is there. Decision height is mentioned, green, orange. Look at this one. Such an old gyroscope. Just black and blue. This is not stable right now. It is not active because no rigidity can be seen. You will see what these points talk about. This again, the advanced version. This is a traditional. This is also very traditional, not used in aviation much, this one. These are the types that you'll see everywhere. A lot is there, a lot. See, pneumatic. I think this is probably, can't say for sure right now, can't see the motor. Could be electric, could be pneumatic, can't say right now. There are vanes, looks like pneumatic. Why looks like pneumatic? Probably because of these yellow chromish, they look like the veins that is there. But you can't say for sure, no direct possible visual references here. This is a turn coordinator. Okay. And students, a basic lecture on these topics is already done. If you are pending to do that, please do and finish it. Okay. This is extra. This is, I mean, if somebody is doing AH for the first time, still you will make a lot of sense about AH. But it's suggested that you finish the basics also. Okay, so you see how the instrument is. Now you have to understand the instrument. Now you have to understand the instrument with respect to your technical terms. That's nothing but being ready for the exams and the specific type of questions that the exam has. AH. Make sure if you have any questions, you will ask. You'll raise your hand, you'll discuss. I am planning to finish this in a sequence, but if you are stuck somewhere, feel free to ask. What do we mean by horizon? Horizontal. And why do we need an artificial horizon? Horizon. It is very important for us as pilots to be able to maintain a level and straight flight. We all know that. The level and straight flight that I need, has to be with respect to the Earth horizon. The Earth horizon is the final line of the Earth that you see from an open field of view. In cities, you cannot see it unless you go to a very high height. Around sea, you can see when the sun sets. That's the place, the horizon. We need artificial horizon to differentiate between where the ground is and where the sky is. My job here with respect to this situation is to keep my aircraft in the center like this. If I'm able to keep my aircraft here, my aircraft is in a straight and level flight. This is when I am looking there. So I'm looking at the aircraft from rear or behind. It means I'm going into the pitch. I'm going in the sea right there. How do I ensure that my aircraft stays this on the horizon? I create an instrument called gyroscopic horizon or artificial horizon. And that instrument created is based upon gyro. When that instrument is designed and made, I get an instrument that is having an indicator. The indicator has my aircraft symbol like this, rear view. You see the tail of the aircraft. And it will show me the ground and it will show me the sky as it is in real life. This miniature aircraft is fixed with real aircraft or housing or cage or glass, no matter what you want to call it. It's not the miniature aircraft that will be allowed to move in the instrument, although in reality, your real aircraft is the one that is moving and your earth or your horizon is considered to be still. Here in this instrument, the aircraft is required to be stationary, and as per gyroscopic instruments, the horizon itself will be tilting right or left. So the direction in which horizon is tilting, you have to understand it in the reverse way to understand where the aircraft is going. And it becomes very challenging for someone who has not tasted it. Some people who do simulations here and there, some people might be able to see it. But when these sketches come in the exam, it becomes difficult to figure out. Now, let's just assume my aircraft wants to bank left or my aircraft wants to bank right. What is banking? Simple. This is banking left. Now I'm looking at the aircraft from rear view. So from my angle is what I see is what I see on the instrument. From your angle, this is what you will be seeing on the miniature aircraft. Exactly this tail. So everything is in the direction of motion. So with respect to you, okay, this is turning, this is what, banking right, and this is banking left. You need to bank to turn. You need to bank to turn. Simple. Plus, look from the side view. You need to climb. Sometimes you have to pitch up. Sometimes you have to pitch down compared to the horizontal. Pitch up, pitch down can be measured or controlled with respect to observations, not through flight controls, can be measured with respect to this artificial horizon. And the bank right and left can also be measured with respect to this artificial horizon. So this artificial horizon gives me two moments, one in the plane of banking, other in the plane of pitching. So it's a gyro that has 2 degrees of freedom. Okay, can move in 2 planes. But gyros that have 2 degrees of freedom, generally you will see they have 3 rings, not 2 rings. The third ring is nothing but cage. If you are not thorough with these things, you'll think that certain gyros will have 3 degrees of freedom also. If there are, there are. Then the second point comes when you're keeping reference of a gyro with respect to its axis controlled to something, it becomes tied gyro. There could be spring, there could be gravity, or there could be a fixed star in space. The first definition that we see, that comes with rigidity. The axis, when maintained with respect to the Earth's gravity, vertical or horizontal, whatever the case, those are called Earth gyros. They are tied gyros tied to certain reference. If they are tied to Earth's gravity, then they are called Earth gyros. So your AH is a Earth gyro. And because it has to be tied to the gravity, the axis of AH is a vertical axis. And the gyro is around it like a drum. So it's a vertical axis, Earth gyro, tied gyro, 2 degrees of freedom. 4 important points in one sentence. These are first level of questions in your navigation exams. Everybody thorough with these 4 points? Do I need to give it to you in writing? What did I just say? AH, vertical axis, Earth gyro, tight gyro due to Earth's gravity, 2 degree freedom, pitch, and roll. And what is the 4th point? What is the 4th point? Students? What is the 4th point, students? No one? Not answering? Anyone? It has 3 rings. Karishma is the only one who is even trying to give me an answer to this. Good job. It will look like it has 3 rings, inner ring, outer ring. The third ring would be the frame of the assembly. Students, are we following? Chaitanya, Muskan, Nukul, Jyotsna, Gulshan, Prerit?
Affirm, sir.
If we are following, then we are not answering, students. कोई कुछ पूछता है तो जवाब देना चाहिए ना. Artificial horizon is also called as attitude indicator. Why? Because it shows the attitude of the aircraft. Whether the aircraft is too egoistic? No. Attitude as in if the aircraft is straight and level, or if the aircraft is in pitch up or nose up, pitch down or nose down, or if the aircraft is rolling to the right, that is banking to the right, or rolling to the left, or banking to the left, or in a climb and bank position, in a climb and bank position, in a ditch or a dive. This will be termed as dive for AH. Dive in the right or dive in the left. Attitudes. We need straight and level attitude. So my AH gives me information with respect to what? My artificial horizon provides me, the pilot, with information in terms of the aircraft's attitude. Gives info to pilot about aircraft's attitude in PITCH pitch and ROLL roll. Very important. It is a primary instrument. When I say primary instrument, as important as a primary control surfaces. Why do you need it? Can a pilot not just see outside the aircraft, look at the horizon and maintain its wing or its view perception with respect to the horizontal? Yes, it can be done. The main impact or the main use of this artificial horizon comes when poor visibility renders the pilot not capable or less capable to observe the horizon. If you cannot see the horizon, how will you be aware whether you're straight or level or not? That's when gyro will help you. As long as it has those properties of gyro, as long as it doesn't have those errors. Now this display unit. So this is the display unit that you see right now. This is the display unit and the other will be the functional unit inside. So the display unit is much more important to you. In the display unit, what do you have? What do you see on the screen? You have a miniature aircraft which is fixed. This miniature aircraft shape, they call it. They don't call it aircraft. They say it's a miniature aircraft shape, or they call it, a more common word is gull wing. This gull wing looks like W. And it is something that is more commonly given to you. That gull wing looks like the logo of Wonder Woman last movie. Many people have used this in their symbol. Earlier, WWE, WWF had symbols like this. This is gull wing. Now, this is more common instead of an aircraft. What do you observe in this gull wing? That is a key to understand these instruments. Observe the nose, which is this. Okay. Observe the nose and observe these wings. I'll color them in yellow. These three will always be in a straight line. Remember that, like aligned with each other. If they three are aligning with the horizon, then you are straight and level. If they are not aligning with the horizon, then they are not straight and level. Not level. This is level and straight. Straight and level, not level and straight. Both can be visualized. But how do I know if this is above horizon or below horizon? If it's above horizon, it means horizon is below me. Then it means I am in a pitch up attitude. If it is below horizon, it means the horizon is above me. It means I am in a dive attitude. How do I make out whether it's below or above? Because a part of the wing is above, a part of the wing is below. In this example on the right. So for you to keep an eye correctly, to just look at the picture and know what the correct deal is, focus on the center point, the nose. If this nose is below, then you are diving. If this nose is above, then you are pitching up. So your pitch attitude can be reflected where the nose of this gull wing is. Is it above the horizon line or below the horizon line on the artificial indicator of the attitude of the aircraft? Okay. Second thing, this is not how the design is featured. Why? Because this is fixed. The gull wing is fixed. Miniature aircraft shape is fixed. So how would this picture be represented then? Just twist it. Just twist this to make your gull wing straight. And if I twist this to make my gull wing straight, what do I get? I get my horizon also twisting by the same value, and I get my horizon to be like this. Now, this is how this representation is given to you, something that can confuse you as a beginner, as a CPL student. When it comes to theory, of course, practically practical pilots with CPL in hand don't know much in detail about these instruments other than the primary relation that they have with respect to their checks and flights. So it still becomes difficult to answer questions in the exam. So for you, this can further become confusing. Now, where are you? Are you banking right or left in this case? Give me your answers. Here I knew I am banking right. Right में नीचे गया, वो right हो गया. This is left, this is right. इसमें कैसे पता चलेगा? अभी तो कॉपी पेस्ट है तो राइट है, बट इसमें पता कैसे चलेगा मैं राइट में बैंक कर रहा हूँ? My wing is also below the horizon. If it's my right wing below the horizon, I'm going right. It's my left wing below the horizon, I'm going left. These are just different techniques for you to easily master reading this instrument. Any questions so far? So here I face that this aircraft, both the cases, like how the instrument shows and what the actual aircraft is doing. On the right, what the actual aircraft is doing. So by how many degrees am I pitching down? I need a line for that, like this in the center. And then by what angle am I banking to the right? That will give me roll bank angle. So older instruments had 60 degrees, 110 degrees for banking and rolling, for pitching and banking. Now modern instruments have increased for the gyros to measure, and such questions come in the exams. How much? So modern day gyro horizon will give you unlimited, no limit bank indication and pitch up, pitch down up to 85%, 85 degrees, as good as 90 degree. Up to 85, it will give you pitch angle. 85, imagine what is 85. It's not even a safe. This is 85. It's not even safe for us. This is 85, nose down. This is 85, nose up. Not safe. This is 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. Like this. How to read? Is this banking right or left? And is this pitching up or down? So banking, check. You might be thinking, sir, एक wing तो उसका ऊपर है ना, तो ऊपर भी तो हो सकता है वो. I'd be like, of course, it is possible. Good thinking. So how do we know exactly and how do we verify the confusions? There will be markers to mark the bank angle also. And those markers can be up of the instruments or they can be on the bottom of the instruments. And if you'll carefully look, the markers would be pointing there. So your job would become much more easier to spot what is happening. Here it is banking right or left. It is banking right. Is it pitching up or down? The nose is down. It is pitching down. Bank right, pitch down. Two indications from my gyro. If I show you that, so I'll make all horizons, let's take green. All horizon lines I'll make in green for our examples. And we'll make this. straight and level aircraft. Okay. And no pitch, no down, straight and level. That is the meaning of straight and level. Here, this aircraft. What do I say about this aircraft? This aircraft is level, as in there is no bank. It's level, but its nose is below the horizon. It means it is level, but in a pitch down attitude. What about this one? Where is this aircraft? This aircraft is level and pitch up. This aircraft is level and straight. Level and straight. Level and pitch up, pitch down. What about this aircraft? This aircraft looks exactly similar to the aircraft on the left with a slightly higher pitch angle, if you could see or not. Again, level, pitch up. So what is changing? Is the fixed aircraft moving? No. The line of the horizon, the line of the horizon is changing. So the first or the second, which of the gimbal rings is moving, that gimbal ring will be attached to the horizon line. And with your precession happening or whatever movements of gyro will be happening, you will be getting an indication outside as per this. So what will be movable? The horizon will be movable. So when the gyro is not powered, when the aircraft is off, your horizon would be all like world twisted up and down or sideways. So you need what is called as erection systems in all gyros. You need to provide RPM. RPM could be with respect to pneumatic, suction, or electric motors, and give it time to build up that RPM, which gives its rigidity and comes to a stable condition. So you will see words like fast erection systems are needed for gyros in flight, because gyros, such as attitude indicators, have errors whenever the aircraft is accelerating or turning. If you have done compass, you know, acceleration, deceleration errors. So AH also has acceleration and deceleration errors based upon which you get questions in the exam. And it's a very simple thing to understand, which I'll be giving you right now in a table. But before that, this is more confusing than that theory. The theory you just have to memorize. This here you have to understand. So now when I have to understand the other aspect of my gyro horizon, then my aircraft will always remain fixed because of the design of the instrument. So this is rule number 1, remember. Otherwise, our logical minds will always tell us that aircraft move hota hai, horizon nahi move hota. So you'll always mark the opposite answers as your correct answers in the exam. And you will be like tired and fed up and wailing and slapping the bench. मेरे को गलत आंसर क्यों आ रहा है? You'll be like, अरे, tell your mind, it's not the aircraft that's moving, it's the gyro. So जो आपको सही लग रहा है उसका opposite होगा यहाँ पर. Oh. Then that eureka moment will come in our mind. So the game, to make it easy for you to spot, is just to do with the orientation of where the horizon is. Your aircraft is going to be fixed. Everything else will move. The markings will also move. So let's talk about left. Okay. Pitch up and pitch down is very easy to understand. Okay. Pitch up and pitch down is very easy to understand. You just see the point of the center of the aircraft shape or the gull wing and should be on the horizon for a No pitch attitude. Above the horizon, you are pitching up. Below the horizon, you're pitching down. I'm making this an horizon. Okay. Then I'm making this. Be very careful. Okay. Take your time. You don't have to rush. Okay. We'll take the first column and the next column. Row wise we'll go. So the first one is this. Second one that I'm making is this. And the third one that I'm making is this. Now, carefully look at the points that I've told you. The first one, the W is on the horizon. The point of the W, the gull wing, is on the horizon. So there is no pitch. When there is no pitch, it is regarded as level flight. So this one is level flight. What about roll attitude? Am I rolling to the right or am I rolling to the left? Any guesses?
Left.
Karishma, very good.
Sir, left.
Very good, Prerit. Students, try answering. I want you to learn with me. Muskan, good. Jyotsna, good. I have your answers in the chat box. First one is level, and it is banking left. Second one is not level. Is it pitch up or it is pitch down?
So pitch down and banking left.
Very good. It's diving. Nose down, pitch down, diving. It is diving and it is bank left. And the third one, the nose, the center of the gull wing is above the horizon. It will be climbing or pitch up or nose up attitude. Climbing, bank left. In your instruments, you might be given now focus on sky blue color. This point here, and there will be a marker small. Then there would be graduations like this on both sides. In your textbook, such are the diagrams given to you. So you see this much angle is 90 degrees and this much angle is 90 degrees. So if there are 3 dots, then every dot is giving you 30 degree angle. So if you are here, or if you are here, 30 degree, 60 degree, 90 degree. You get that readings as per that index line or any indicator line that you'll have that will align itself with the instrument marking. All you have to do is just look at where the marker is and you will get to know what is your bank angle. Now you're required to maintain certain fixed bank angles for certain turns for certain aircrafts. So your instruments will show whether you're going out of that limit or not going out of that limit. So you need that indication for bank as well. And your turns are incomplete without banks. Banks, you cannot just horizontally turn an aircraft in air. So if my indicator will be somewhere in between, then I know it's 15 degrees. If it is before that, I know it's 10 degrees. If it's after that, I know it's 20 degrees. Like that. You have to make assumptions. Otherwise, the diagram is so simply given to you that it becomes so difficult to even understand that. So based upon wherever your pointer is, straight and level, where will be your pointer? Straight and level, your pointer will be in the center only. But here the bank angle will change in this one. And in this one, the bank angle will show me not 0 degree, but maybe approximately 30 degrees. So the pointer will be somewhere here. Then I'll have 60, then I'll have 90 like this. 30, 60, 90. Like this. If in the other instrument, if I have 30, 60, and 90, if in my other instrument, diving, banking left, if my marker is here, so it means 10, 20. 20 degree banking left and the aircraft is diving. So much of information I have got. Bank angle, direction of bank, plus pitch, attitude, and the value of whether how many degrees I'm pitch up or how many degrees I'm pitch down. All that with the help of just one instrument. This is why it is your primary instrument. And if you don't know gyroscope, if you have not studied gyroscope, then you should, because your primary instrument works upon the gyroscopic principle. In the third one, climbing, banking left. Again, there are pointers 0, 30, 60, 90. You're banking left. And you're climbing. If I say your indicator is somewhere here, so you could say it could be 20 degrees, 25 degrees, close to 30 degrees, but it is on the left. The indication on the left can also be made out simply by looking at your indicator. Your indicators are all on the left side. They are marking the circle on the left side. So your job in the real instrument becomes much more easier to see what the information is represented. But you as a pilot would already know because you have taken that turn. You know whether you've gone right or you've gone left. But here, while learning, you have not made that turn. So you will not know, so you have to guess. That's why it becomes difficult. So these are the techniques to understand and refer. So for all my turns that are right, I know it is so easy now. Level flight, but bank right would look like this. Level flight, no. Banking right, but diving would look like this. And banking right, but climbing would look like this. And my indicators with respect to the bank angle will also be on my right, and they'll point to exactly what the angle is. You don't need to worry. They will measure the angle of the aircraft and give it to you. You just have to read it from the instrument. So if here I was taking 30 degrees and here I was taking 20 degrees, and if here I was taking 25 degrees, the same. 30 degree will be here, 25 degree will be here, and 20 degree and 25 will be here. So pointers I'll color in red so that you understand these are the pointers. Indicators. You'll have these indicators, but they're so tiny you'll not be able to see. So now you know you have to look at the indicators. If the indication on the degree value is on the right, you're banking right. If the indication is on the left, you're banking left. Or you can remember where the horizon is tilting. Horizon will tilt in the opposite direction. If your horizon is tilting like this and it is tilting to the right like this, then you are turning left. Exactly how the left side of our section is. From level, it is going like this. It means it is going on the right. From upper side, it means my turn is left. It stands true. However you want to fix it in your mind, I want you to fix it in your mind right now. And don't wait for the exams or don't wait for final revisions. Otherwise, I would not teach you like this. Okay. I'm thinking of seeing how soon you can finish this, so I can at least give you a test before this week ends based upon this topic at least, so that you can guarantee 2 to 3 marks in the exam extra on any bad day. So do everything right now and discuss doubts. बाद में मेरे को फालतू में trouble नहीं चाहिए, इसी को लेके बैठे हो आप लोग फिर. It's not difficult. Sit and master. If you're stuck, you talk to me. Understood all essential elements of the display? Any confusion? Feel free to ask.
Sir, I didn't understand the part where how the angle is measured, like 20, 25, 30.
It is measured with respect to whatever your axis of rotation is fixed with, the vertical axis. Measurement with respect to your bank angles is the angle measured between the horizon and your longitudinal axis. So one of the gimbal rings will be aligned with the longitudinal axis. One of them will be aligned with the lateral axis. The one with the longitudinal axis can give you pitch up and pitch down. The one with the lateral axis will give you the bank angles. So inside the mechanism is designed in such a way that if you're turning by this value, then the rigid and the turn both are measured with respect to the orientation, and the mechanism is such that the pointer will directly point to that degree only as per the instrument. So students, it's a very good question. You will be given, sure, Sandeep, you can keep, you will be given points with respect to gyros, whether they rotate about an axis, around an axis, along an axis. About means axis ke right, left. So if you want to talk about pitch, then pitch happens about the longitudinal axis. क्योंकि ये बीच में आता है. Bank happens about the longitudinal axis, bank. And pitch is going up and down. So pitch happens about the lateral axis. But when we talk about along, then pitch happens along the longitudinal axis and bank happens along the lateral axis. So be on the lookout about and along. If it's about, then who is in the center? If it's along, then with whom are we traveling? But the measurements are always made with respect to the horizon only. Pitch also, this also. And the horizon for you to align, it is very important before you take the aircraft out for taxi and departure. That is one of the most important points that you should know, that make sure you don't adjust your artificial horizons for errors, this and that in flight. Never do that. Even if you know, you do it on ground only. So what happens if you are parked on ground? Once your gyroscope instrument has been erected properly with respect to the RPM, then you observe. If you are straight and level, the aircraft of course is straight and level. The runways and the aerodromes are designed that every aircraft parked will be straight and level. Then if your horizon and your gull wing aircraft are not straight, then you have to have some adjustments to be made before you fly. And then you fly. Mostly in your case, you will already have aligned, but that becomes a part of your pre-flight checks also, even if you go for type-rated aircrafts. If in your pre-flight checks, you don't have all instruments aligned properly, then you have to go through the checklist and do things again to see whether they're working or not. So the angular measurement is simply between where the axis should be and where it is during certain maneuvers. So as long as my aircraft is in straight and level flight, my gyro rigidity is aligned with my aircraft being level and straight. The moment I'm turning right or left, my gyro will still remain straight. Remember, I showed you that example. Like this also, gyro will remain straight. So if I'm like this, gyro is here. And if I'm turning right, this is not turn right for me. This is turn right, because if I'm turning right, the horizon will become like this. And the angle between this hand and this hand, like this is the horizontal, and now this. The angle that you see will be the bank angle for you, but in the opposite direction. Generally, the bank angle we measure with respect to if my wing is gone down, then this is the angle we measure. The wing going down is what we measure, not the wing going up. So a gyro will be aligned like this. And when the aircraft is moving, the fixed aircraft that is attached to the casing, that remains fixed. But the horizon moves to simulate that the aircraft is moving. So that what happens when you are looking at the earth outside And when you're looking at yourself, so right now studying the instrument, you're seated in a horizontal place. But when you are looking at bank left, what will you have to do to align this first diagram 30-degree bank left? You also have to do this along with the aircraft, because in reality, you will do that in space, 3 dimensions. When you do that, you realize, okay, now my gyro and my outside are ditto copy of each other. And that's why the gyro is designed such a way that when you are turning left, you see what you will see outside on the inside. So when you are flying, you don't see the opposites. You see the real thing only, because that's how it is designed. When on ground, you see the opposites because you're not moving in that orientation. So that's another level why you get confused. Learning. Please don't get confused. It's very simple that way. And if you have access to any FSX like Microsoft simulators, even the old ones, just do one simple ride and you will be able to see. Just do a simple takeoff and turn left, right, and observe this instrument on that simulator. You'll be like, अरे यार, ये तो मैंने सोचा ही नहीं ऐसा भी होएगा. मैं तो अभी भी टेक्स्ट बुक का ही सोच रहा हूँ या सोच रही हूँ. How is the angle measured? Remember, angle is measured with respect to horizon, straight and level. From there only, if the aircraft is banking right, the angle would be measured from the horizon to the bank angle, as in what is the angle difference between the lateral axis and the horizon to give me bank angle, and longitudinal axis and the horizon to give me pitch angle. Questions? Think. Students finding it too complex, go easy with yourself. Students not finding it complex, take opportunity of the time. Sandeep, able to understand?
Yes, sir, I do.
Chaitanya, any doubts?
Negative, sir.
Prerit, Gulshan, Jyotsna, Karishma, Muskan. Where is Rohita? Okay, Rohita is not attending. Vishnupriya is also not attending. No problem. Typical limits, modern limits. Okay. Pitch, roll. Roll, bank is one and the same. Roll is a motion, bank is measurement. Pitch, roll. Earlier, we had plus minus 60 degrees of pitch attitude and 110 degrees of roll, right or left, both sides. Okay, right, left. Modern instruments are giving me pitch attitude up to 85 degrees plus minus, and they are giving me roll, they are giving me complete freedom in roll. What will happen if you overcross limits? When your aircraft is over pitching, then the capacity for the instrument to sense. Modern instrument, you are sure aircraft might not over pitch that much. But if it's an older instrument, a typically basic instrument, students, it's not 100, okay? It's 110. 110 degrees. Roll, right and left both. 110. Make that correction, okay? Just typing. If you overcross the limits, gyro will topple. What is topple? It's a vertical gyro. It will topple. It will lose its rigidity. Toppling is just gone. Gyro gone for good. We don't want our gyro to topple. Precession is fine, can be controlled. आप लोगों को समझ आ रहा है students? Easy? If this much you have understood, I only have to give you important points to remember. Job will become much more easier. बाकी डेप्थ में आपको नहीं जाना है अभी, इससे ज्यादा डेप्थ में आपको नहीं जाना है. Just listen, students. Good. Just follow my voice for a second. Over cross limits, your gyro will topple and it will give violent and erratic movements of the horizon bar. Violent and erratic. Erratic means erroneous, not right, sounding as if there are mistakes. It will give violent and erratic movements of the horizon bar. The horizon bar will keep moving like this, like this, like this, like this, vibrating here and there, everywhere. After toppling, gyro can take, if it is possible, to erect the gyro again. If it is possible, then it can take up to 10 to 15 minutes for the gyro to self-erect in the rigid form. If you don't need this, then you need fast erection systems, which are there in your electrical gyros. Because in your electrical gyros, you have motors. In order, if the electric driven gyro is toppling, we can increase the voltage supply automatically by initiating the fast erection system. There will be a switch. So when you increase the voltage, the motor increases its RPM, rotates at a higher pace. Rotating at a higher RPM will increase the rigidity faster. By increasing the rigidity faster, we erect the topple gyros quickly. So fast erection systems are needed. You can get points on these questions or these topics. So if you do want to save 10-15 minutes, which you know are so important, like of course, then you need fast erection systems. What about initial erection of the rotor? For the first time when you're starting the engines, if it's a new air-driven or pneumatic suction type gyro, then the air and everything comes from the engine oil. Everything comes from the engine. If it's electrical, then the electric supply comes from the engine to the alternators and through the alternates to the bus bars and from there to the, again, whatever systems are using it. So initial erection of rotor has a design function. What is the design function? How? By making the rotor very slightly bottom heavy. As in, when the rotor is designed, the bottom part of the rotor should be slightly heavy. This heaviness helps in quick initial erection when the aircraft is being started. Very slightly bottom heavy rotors. A very important point to remember if you get questions like initial erection, how do you make sure? You'll say, I'll make sure that the rotor is a little heavy in the bottom. The problem is not this. The problem is fine. The problem is that when you are in the air, the system is very complex to maintain this rigidity. You have to keep the gyro contained with respect to a lot of other mechanisms also. A simple gyro is not that efficient unless it's controlled. So how do you control the gyros? You control the gyros through air-driven or suction pumps. And this suction pumps, they are all generated through air that is exhausted out from the engines only. We call it bleed air, extra air that comes out. In electrical artificial horizons, you have torque motors and you have mercury switches. So let's compare. What is mercury? What is mercury switch? Mercury switches are types of switches we don't use much here in our country, but abroad it is too much in use. Their temperature regulators and everything often have mercury switches because mercury expands and contracts. Mercury has good properties with respect to weather, so that can be used. Air driven and electric. Air driven, okay. It can be driven through suction or it can be driven through air. All right. There are generally 4 slots, and to balance, you have vanes or pendulous vanes. They are hanging as a pendulous system. 4. You don't need to get into much depth beyond this right now. Keywords are very important. So if you don't understand what these mean, understand these are paths where rotor and a balancing of the rotor is there. In my electric artificial horizon, I have electricity, I have torque motors. Torque motors are motors that have good force, good power during start. Most of the motors that we use to drive mechanisms are torque motors only. So rotors, we can say rotors with 4 slots, and to balance, we have vanes or pendulous vanes. Electricity, rotors are torque motors only. And to level, we have leveling, or in other words called as mercury switches. These are the keywords. How the leveling is happening inside the housing, you'll prepare for ATPL students. Remember, only this much part you'll have to study for ATPL for topics. How the inside is working, inside. If you are done with your studies and everything, it doesn't hurt to read before your exams later on. How much of suction is created in this air driven? How much? They could very well ask this question. Suction created is up to 4 inches of mercury. Now students confused thinking, sir, mercury switch to artificial horizon में आ रहा है. ये air driven, engine driven, air driven artificial horizon में ये suction 4 inches कुछ समझ में नहीं आया. I'm like, I agree with you. But then don't you think, or can you not recall thinking that inches of mercury is also a measurement of pressure? Think about it. How much? 29.992 inches of mercury is the ISA mean sea level pressure. So here 4 inches of mercury means the pressure. Suction of 4 inches of mercury. Now, if you have the converter, then you can convert it into HPA and see how much is it in HPA. So suction created is up to 4 inches of mercury in an air-driven pump. And the rotor moves at an RPM of 15000 revolutions per minute, 15,000 RPM. Your electrical motors based generators will have much more beyond this. How much do you think is the RPM for electric gyros or electric horizontal artificial horizon? How much do you think? 20,000, 25,000, 1 lakh, 22,500. Not much for 50% more than the pneumatic. And this adds to my rigidity. And because it adds to my rigidity, my errors that I see in air-driven pumps are nullified or reduced in electric AH. Not air-driven pumps, air-driven AH. So whatever errors you're going to see will be for air-driven mainly. The impact would be negligible or very less if you're using air-driven ones because of the increased rigidity in itself. So such questions are very simple to answer. But if you're not well versed with it, then you might be confused. You might be getting confused in the exam. Soak everything in, take a minute or two, go through everything that we have studied, go through if you have made any go through if you have made any notes, and see if you have any questions so far. After that, I'll give you a table of errors. Make sure you write it well and note it well. Acceleration errors and turning errors. Very simple. I hope you're reflecting and soaking on what has been told. I've been speaking non-stop since how much? 1.5 hours. If I continue talking, I'm worried आप लोग bouncer जाएगा सब कुछ. That is one reason why I want you to think and take a pause and revise, because आगे का चीज skip हो जाएगा नहीं. Second thing, I'm giving you chance to ask me if you're confused anywhere. Now, after this, what you will be doing after the session, I'll ask you to read through the textbook. You'll find it in the instrument textbook, chapter number 13. I would want you to read the points that we have covered, extra points that we have not covered. If it's too far away from us, don't read it. You will understand this is not to be read. That's it. The points that I've discussed, if you come across those points while reading, of course you will. If you come across any discrepancies, you will discuss those with me. If you have any doubts, you'll discuss those with me. If you don't have, then that would be final revision for you. So you'll be ready for the test, maybe by tomorrow or by Saturday. Let's see, I'll tell you all, I'll surprise you all. Simple MCQ, 10, 15, 20 questions at max. Same Google based. I'll share with you all. You also want to practice, right? Exam type questions. So that's the idea. Don't wait for the end. Don't wait for final revision. Do topic-wise final revisions with me live right here, right now. And remember them till the end of your exams and use this strategy. Don't follow any other strategies that is not as efficient as this is. If you are following, keep me in the loop. Okay? Otherwise, you'll panic in the end. No questions? See, I'm showing something to you all. Read lines what FA is giving us. Read this. As the airplane banks, the relation between the miniature airplane and the horizon bar depicts the direction of turn. The relationship with words, students. Nobody is relating the bank with direction of turn so far, apart from the few points where I said bank and turn go hand in hand. What happens in the examinations? Questions can come from anywhere. CA, FA, EASA, all other things, because it's all universal. What we are learning, UK, there's no originality in whatever subcontinents are there around us. The materials come from there only. For you to solve the exam questions, you have to be very, very smart, because this depicts the direction of turn would be a blank. There would be three options. And the two other options will play around with bank, 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 but the correct answer would be direction of turn. So please write this point as an important note. As the airplane banks, the relationship between the horizon bar, the miniature airplane and the horizon bar depicts the direction of turn, whether I'm going right or left. If I'm banking right, I'm going right. I'm banking left, I'm going left. I know how to read banking left, how to banking right. So now I know reading there, I can determine my direction of turn. So now you attach the direction of turn along with your displays in all the three. Right bank, right turn, left bank, left turn. The second, the miniature airplane or airplane shape is adjustable and should be set to match the level flight indication of the horizon bar. Exactly the point that we discussed. Aircraft start होने से पहले match कर लो after erection. It is adjustable, the knobs and everything, and then you fly. Such great is the design of the instrument, students, and it doesn't even require electricity. Air-driven pumps I'm talking about. Imagine, genius of people. Look at this. This is very nice. It shows you the aircraft and it shows you how the display would be. Climbing left and bank. See, here the gull wing and the aircraft is so different, but the relationship is same. The nose and the wings are aligned, and if the nose is above the horizon. The second thing, look here. See, these are the markers for your bank angle. This aircraft is banking tremendously. Where exactly? 30 degrees, I would say. Here the markings are above. We saw the markings below. But a left bank, here also, the marking is on the left only. So, here I'll show you. So this is the center one, 0 degree. This is 30 degree. This is 60 degree. And this is 90 degree. These are the type of instruments you'll see more often. The ones with the lines on the top for bank angle. This again is 30 degree, 60 degree, and this is 90 degree. So here you see behind, there is a brown rubber line kind of a thing here. This is that indicator, which is aligned with this nose of the aircraft like this, see, in this case right now. So there you see, and it is on the left, so you are banking left. The left-right relation is the same. So the indicator is on the left, you are turning left. Think about this. Here the brown index is right in the center of 0 degrees. Here aircraft is not banking anywhere. Plus, let's see the nose. The nose is above. So the aircraft is pitch up, but no turn. Let's see what's written. It's a level climb. It's level means no turn, and it's climbing. Pitch up, level, level climb. Don't get confused with words unnecessarily. See, my aircraft from behind is straight. Exactly. This is how I will be doing. This is how the instrument would look. But in real time in the cockpit, I'll be able to visually make sense out of it. Level, left bank, how much? 30 degrees. Level, Y level. You see these little lines here? These are showing pitch angle over here, nothing else. You will get many lines like this up to 85 degrees. So that those lines are in the center. So here they're only going 5, 10, 15 degrees. So probably for this aircraft and this aircraft particular, this instrument maximum could be 15 degree only for this instrument. Probably that's why they don't have much more indication in this with respect to pitch. See, this one is straight and pitch up 5 degrees is what I could see. See the pointer in the center. See your bank scale, miniature aeroplane. This line is the artificial horizon. And then level right bank. 30 degrees to the right. The marking is on the right quadrant of that. Very easy to decipher. Now we have a comment. Sir, turn coordinator gyro will also show us turn and bank angle. Is it more modified one? One of the gyro instruments is used to determine just your bank angle. Control turns is what we call it. This is not a modification of that. That is not a modification of this. That is in itself something else. This is in itself something else. Both have equal weightage in the cockpit. That might not be a primary instrument. This is a primary instrument. When it comes to turn coordination indicator, turn and coordination indicator or slip indicator, try to go through your notes, students. A clear distinction is made. One is the modification of the other in between the two. So one that has bank angle as well as slip, that is turn and bank coordinate, the more modified one. And the other one will just either show you slip. So slip and skid is through the tube, glass tube. उस पे भी मैं आपको करवाऊंगा exam prep session with respect to questions in short. But yes, no, these are two separate instruments. The two type of turn and coordinator are one is the more advanced of the other, but these are two different things doing different things. Different gyros, different principles. Rigidity precession is same. Horizontal, vertical is different. There is an adjustment knob here. See, descend, but level. Descend, left bank. Descend, right bank. Should see which quadrant, right side. Simple. 1 mark in my pocket, 2 marks in my pocket. One by one, we get there. Any questions? Fine. We'll take a short breather, 5 minutes, and we'll start with isolation errors. Okay, so come back at 1805, everyone. Short breather, okay? Students, let me know if you're back. Chaitanya, Gulshan, Prerit, Jyotsna, Karishma, Nukul, and Sandeep. I hope you're back.
Yes, sir.
Gulshan. Now, students, remember, I mentioned that it is very difficult to maintain that rigid position. How are we maintaining that rigid position? In air-driven AH, it is done by those pendulous vanes. And in electric, it is done by mercury switches. Okay. Now, what happens during acceleration? The vanes are affected due to the impact of the acceleration or deceleration. Acceleration, straight and level. An example of straight and level acceleration could be takeoff. Now, before that, I want to tell you all that when the aircraft is on ground, many aircrafts on ground are designed to have a certain nose up attitude or nose down attitude, depending upon their design. Concorde was one of them where the nose was a little down. So whatever there is setting for your aircraft parked should be 10-degree nose up on parking. That should be the system of straight and level erection before you go ahead with the flight. It should not always be with the horizon. If your aircraft wants 10, you're on horizon, then you are 10-degree less. You'll have to adjust it and bring it up to 10-degree nose up attitude and then fly. Remember all these little points. So due to acceleration, these vanes are impacted. So there will be errors. Due to turning, there is a centrifugal force and a centripetal force when the aircraft is turning. These forces are, one of these forces also causing the vanes to be disturbed. So wherever you have vanes, you will have more acceleration and turning errors. The errors that you have in air-driven AH are very, very, very highly reduced. Why? Reduced in the electrical AH. Why? Because of high RPM increasing high rigidity. High rigidity decreases the errors. Decreasing the errors increases more accuracy of the electrical AH. So there will be pointers in the text that talk about how are you fixing the acceleration, deceleration errors in AH that is electrically driven. So there will be cutout switches, roll cutout switches in electrical ones. So those will be the keywords: roll cutout, pitch and roll cutout switches, wherever the leveling switches are. So there are 4 pendulum vanes in your gyro at the bottom type. Just remember this much. Okay. How the air goes and all, you can do that later on in future when the time comes. When it comes to electrical, I have 2 leveling switches. One for pitch, one for roll, like that. And then I also have pitch and roll cutout switches, where if I come across any of the errors, then the mechanism in itself will prevent the instrument from giving me the wrong readings. And one of the reasons why during turning, you are facing turning errors in the pneumatic or the air-driven pumps, which we'll be seeing now the errors. One of the main reasons is that because the bottom of the rotor is heavy, which is important. Because it is heavy, during acceleration, the error is further reduced in AH. Because in AH, the housing, the rotor, the heaviness is very less compared to the pneumatic one. These are simple points. Understand, mark the correct answers. It is like that. So the problem about errors is not in electric horizon. How it is fixed is mentioned, the points are discussed. There's only a small para for you to read in the text. What is more important is with respect to your pneumatic or air-driven artificial horizon, what are the errors? Now, rotor direction for these gyros that we are studying is anti-clockwise. So the rotor is moving anti-clockwise. So whatever you're going to study is with respect to a rotor moving anti-clockwise. Most of the modern rotors, modern gyros and electric rotors might have their electric gyros, might have their rotors turning clockwise. If in the exams they tell you there is electrical AH with clockwise rotor, then whatever you're going to learn now in this table, you make an opposite of that as your answer. So right now, rotor is moving anti-clockwise. This is the traditional type of rotor. Based upon that, we are facing these errors. That is not the case for compass errors because the magnetic needle will not differentiate. So rotor direction is anti-clockwise, and basis of that, you have to understand the errors. Acceleration error is simple. What happens in my acceleration error? What is the impact? The condition is during acceleration, when aircraft is straight and level, acceleration error when the aircraft is accelerating during a straight and level orientation, that is during takeoff run, or sometimes when you are increasing your airspeed in air also, or takeoff run, then the acceleration error will cause a erroneous or erratic reading. What is that reading? I'm showing you right now, okay? That's all that you have to learn about acceleration error. The reading is very simple. When you are in straight and level flight and when you are accelerating, you get a false, as in it's not the right indication, but the real indication that you see is a false indication. And what is that false indication? That is your aircraft is nose up and aircraft is turning right. Now just think to yourself, you are on the runway, going for takeoff, straight and level, very nicely, rigidly holding the aircraft. But your instrument shows that you are pitched up and you're going right. You might be thinking, oh my God, मेरा aircraft तो कहीं जा रहा है, stall हो रहा है, like कहीं तो जा रहा है, इसको stall भी नहीं बोलेंगे, क्या बोलेंगे इसको? So you might want to correct yourself. एयरक्राफ्ट को थोड़ा पुश करोगे नीचे और एयरक्राफ्ट को थोड़ा लेफ्ट लेके जाओगे, दैट टू दैट यू आर ऑन ग्राउंड. सो यू माइट फील यू हैव बीन लिफ्ट ऑफ और तुम्हारा नोज ऊपर हो गया बट पीछे का टायर नीचे जमीन पे अभी भी टच कर रहा है. इट कुड बी अ वेरी कंफ्यूजिंग सिचुएशन. But then you understand it's just an acceleration error because the vanes are being disturbed because of the acceleration. And the vanes are the main control system to make sure the gyro axis is stable. So the vanes are the main controlling aspect of the device. Pendulous vanes in power air driven and mercury or leveling switches in there. Just keyword simple. वो main है, उनको कुछ हो गया तो gyro में भी error आएगा, उनको सही कर लो तो gyro भी सही रह जाएंगे. It's like that. So straight and level flight pendulous vanes are stable only. Acceleration, they are impacted. Turning, they are impacted. So they are just shifting away from their position. With respect to the design in an anti-clockwise moving rotor, this is the impact during acceleration. During deceleration, it's the opposite of the same. This false nose up turning right can also be read out in different words. Now that's where the exam confuses us. False nose up and false right wing down. Right wing down also means same, right? You are right, taking a right turn. So don't get confused in the exams. Or it could also mean that it is giving you a climbing right hand turn. Same things, different meanings. आप एक ही याद करके जाओगे, दूसरा ध्यान में नहीं रहेगा, वो सामने रहेगा, आप कंफ्यूज हो जाओगे, आप मार्क नहीं करके आओगे, कुछ और ही मार्क करके आओगे. देन विल बी लाइक, ये मेरे को पढ़ाया नहीं. आई बी लाइक, यार राइट विंग डाउन मतलब राइट टर्न ही तो होता है. अरे यार सर सॉरी. सॉरी की कोई बात नहीं, एग्जाम में ध्यान रखना चाहिए था, अभी याद रखना बस. Write down these key points. The pitch error in bracket right due acceleration. The pitch error due acceleration is due to effect of acceleration on lateral pendulous vanes. So there are 4 vanes. Okay. There are 4 vanes. 2 are lateral, 2 are longitudinal, like that. 2 axis, right? So they work in pairs. So the ones that are laterally located on the sides, aligned with the lateral axis of the aircraft, when they are affected due to the acceleration, that's when you get acceleration error. So remember this also. Now it becomes in-depth learning for you students. Like इससे ज़्यादा तो क्या ही वो लोग पूछ लेंगे आपसे, ऐसा हो जाता है. And the roll error, वो fake right turn जो था ना हमारा, false right turn, ये तो false pitch हो गया during acceleration, ऊपर वाला point. And false roll error, right hand turn. Why is that happening? It is, and that is also during acceleration, okay? It is due to inertia of the bottom heavy rotor housing. So the rotor housing in itself is a little heavy on the bottom side to maintain that vertical. Now the rotor might not be able, we might not be able to differentiate the weights in the rotor itself to keep the bottom heavy. It might change the perfection in which it attains the RPM. So what they do, the housing in which the rotor is, the housing is made a little bottom heavy. So the rotor can move, but the rotor, the housing and the rotor are one part only. So it stays vertical that way. So now you go in depth. ठीक है, acceleration में होता क्या है? But pitch क्यों हो रहा है? Because lateral vanes are being impacted by acceleration in a straight and level flight. And roll is happening because of the inertia of the excess weight, a slightly bottom heavy rotor housing. Housing is the key then here. So earlier we said rotor hota hai, there you add, it's not the rotor because rotor has to move freely. It's actually the housing where we get the impact of a bottom heavy rotor. So that due to gravity, it is staying like this as much as it can be. Deceleration in level and straight flight. Deceleration in level and straight flight will give me false nose down, left turn, left wing low, diving, etc., etc. All different ways, but memorize these points and tell me if you have understood the mechanism, how these things are happening inside. Wait for that. The impact and the causes, learn that. Note rotors with clockwise rotation, acceleration, nose down, turn left, deceleration, nose up, turn right. Rotors with clockwise direction. I'm giving you directly. Now don't say, sir, वो opposite में मैं confused हो गया. Write down this also. Most electric horizons and some American air-driven horizons have clockwise rotor spin. Here, American is not a keyword for us, but most electric. But with American, they've added air-driven horizons. So it's not like all air-driven are anti-clockwise. Some American could be clockwise. Most electric-driven are clockwise because generally the motor's clockwise motion is generated like easy for everything else to get power. Otherwise, you'll need some logic gates to reverse the implications of the same. Fine. Quickly write out about turning errors.
Excuse me, sir.
Yes, please.
Sir, most electric-driven rotors are
क्या बोल रहे हो चैतन्य?
I was asking most electrical rotors are these
Most
clockwise.
electric driven AH rotors move in clockwise direction.
Okay, sir.
अच्छे से लिखो स्टूडेंट्स, पूछो जो भी डाउट्स है. चैतन्य सब वेरीफाई कर लो अच्छे से, अभी समझ लो, अभी याद कर लो. ऐसे सोचो बस मेरे को एग्जाम में याद आना चाहिए डायरेक्टली. मुस्कान, यस टेल मी.
Sir, there are total 4 veins. 2 are along lateral axis and 2 are about which axis?
Along
Longitudinal?
lateral, along longitudinal, two axes. Longitudinal and lateral only. Vertical is the axis of spin of the rotor. Yes. अच्छे से पूछो स्टूडेंट्स, हक से पूछो आप लोग. Make sure you are getting things. दिमाग में फिट कर लिया है ना कैसे होता है हमारा राइट लेफ्ट बेस्ट. Now the table for turning error is very simple, but the cause behind turning error is very important. During turning, acceleration is felt for your veins. by your wings due to the centripetal force. Two forces, one goes out, one comes in. Now, during acceleration, when the aircraft is turning, okay, note this point down. When aircraft turns, there is acceleration towards the center of the turn due to centripetal force. Pendulous vanes get affected by horizontal acceleration as well as acceleration due to gravity. Underline horizontal acceleration due to gravity. Why due to gravity? Because you're banking, right? So you're going down. So that's also an acceleration due to gravity. And due to the centrifugal force, you're getting acceleration that is horizontal also. When you're not accelerating, when your speed is constant, when you're turning, still the control system, the vanes are impacted by the acceleration. Because of this acceleration, these two accelerations, giving rise to errors in pitch and roll indications. Okay. I'm writing the table. Okay. Just give me a second. Okay. Do you remember your turning errors for compass, magnetic compass? कितना अच्छे से पढ़ा अपन ने, इतना अच्छे से समझा उसको. प्लीज याद रख के जाना एग्जाम्स में, वो भी आएगा, आ सकता. The turning error magnitude, how big is the error for an artificial horizon? It depends upon a few things. What does it depend upon? It depends upon the speed, the rate of turn, and the type of horizon. Turning error can be compensated. Okay. Turning error can be compensated by there are two ways. What are those two ways? So turning error has two types. Based upon the two types, the compensation can be taken place. What are the two types? One is erection error, and the second is pendulosity error. You might be thinking, "Arey yaar, sir, ये तो और complex हो रहा है." It is not complex. These are just terms. One-liner terms. That's it. ये erection error क्यों हो रहा है? During turn, centrifugal force, not centripetal here, centrifugal force acts on the fore and aft pendulous vanes. When I say fore and aft, these are the ones aligned with longitudinal axis. This effect on the fore and aft, resulting into the pitch error, is called your erection error. Okay. And pendulosity error. What is this pendulosity error? And during turn, the centrifugal force acts on the, what do you think? The weighted base of the rotor housing. So the two things that we have already seen, weighted base of the rotor housing, that impact is called as pendulosity error. That's it. Now, in order to compensate your erection error, you can tilt the top of the rotor axis slightly forward. Remember this. Tilting the top of the rotor axis slightly forward can account for the erection error, and tilting the top of the rotor axis slightly to the left. Remember, simple points given to you simply, explained to you simply. You have to just remember them simply. Don't make it complicated. Erection error to do with the pendulous vanes during turning, where it is impacting the fore and aft vanes. It can be resolved by tilting the top of the axis a little ahead, little forward. And to account for the roll error, that is the pendulosity error, we turn it to the left a little. Left, remember, left. What? The axis. The tilt should be approximately 2 degrees in both cases for air-driven gyros, AH. What are the error indications? Now, error indications. Error को कैसे resolve करना है? Error के क्या types है? Error क्यों होते हैं? हमने देख लिया फटाफट. Now we want to see what are the error indications. We are assuming for the same classic air-driven gyro with anti-clockwise rotors. And this clockwise motion is when you're viewing from the above. Remember that also. Then whenever you are turning through a fixed direction, what is happening to the roll and what is happening to the pitch? This is our table. Like this. So when you are turning through 90 degrees, 0, 9 at 0, your turning error will make you underread the actual reading, as in the indications given to you will be lesser than the actual indications. So the instrument underreads bank angle. When I'm turning through 180, I get correct bank angles. So no error in turning when I'm turning through 180 degrees. When I'm turning through 270 degrees, my AH with anti-clockwise rotor, air driven, will give me during turn, it will overread my bank angle. It will give me more reading than there is. And when I'm turning through 360 degrees, my bank angle is correct. So only when I'm moving through 0900 or 270, underreads my turn angles, bank angles, underreads. So during 0900 and 270, during 0900 and 270, you are getting roll error due to turns. But turning through 180 and 360, you're not getting roll error due turns. Similar to turning errors, magnetic compass. What about pitch error? Pitch error, when you are turning through 90 degrees, underreads bank angle was roll, pitch error will indicate climb. When you are not climbing, it will indicate climb. The turning error, 0900. When you're turning through 180, will also indicate a climb. When you're turning through 270, it will also indicate a climb. The only relief is when you're completing a turn to 360 degrees, the turning errors cancel out. So when you have turned through 360 degrees or made a complete turn, that way also your bank angle will be correct and you don't have any issue at all. So you can say correct angle of pitch. With this example, you will come across a key point in your textbook through this last point, which reads out as the errors due turning are complex and these errors change as the turn progresses. By the time you have taken 90-degree turn, the error was that it is under reading the bank angle and showing you climb. By the time you have turned 90 degree and turned 180 degree, the bank angle shown is correct, but it's still indicating climb. When you're making further turn and doing a 270-degree revolution of the turn, bank angle is now overreading. And still it is showing a pitch climb. By the time I've completed the turn, I've come back to 360. All my turning errors are cancelled out. So completing a 360-degree turn will cancel out your turning errors. And that is very important for you to know. Turning errors will change as the turn progresses and will cancel out after a 360-degree turn. So please write it down. Change as turn progresses and cancel out as a 360-degree turn is completed. The correction applied to the tilt is of the value of 2 degrees, remember. Something to do with caging. What is caging? Try to go through your basic gyro notes and see. If there is a caging option, then you have to uncage the gyro at least 5 minutes before takeoff. Remember this key point as well. You need that time so that the rotor axis aligns with the actual vertical that there is existing. That will be referred to as true vertical. A good gyro, good AH is good. It's serviceable. When in flight, the artificial horizon gives you immediate indications of changes in pitch or roll. It should be immediately reflected to you. If it's not immediately being reflected, then there is some error in the instrument. What is the main advantage of electrical horizon? Higher rigidity to higher RPM, higher accuracy, less errors. Second is that it can have a fast direction system. There are 2 pairs of pendulum vanes. Here there are 2 switches, one for pitch, one for roll. Leveling switches or mercury switches that are controlling or maintaining the housing the way it is. Electrical gyro students are also designed in a way to compensate for the turning errors. Like we said, the tilt can be applied 2 degree. Now we'll manually not apply the tilt. So there might be some functions to do it, right? The electrical horizon is made in such a way that whenever the turning errors of negligible value are also happening, then the rotor axis will be slightly tilted away from the true vertical, the actual vertical axis of the aircraft you can consider here. And the horizon bar also should be compensated in the same way, a little bit of compensation away from the true. They should not be aligned. They should just be compensated. How much of the tilt should be applied? Air-driven 2 degree tilt is mentioned. Here, the tilt value will depend from instrument to instrument as per the manufacturer. Remember, acceleration errors are minimum in electrical horizon. All the reasons, there are cutout switches also. The rotor housing is less bottom heavy. Plus, rotor speed is so high that rigidity is high, acceleration impact is very low. Just write down the cutoff switches for an electrical driven gyro based AH. The mercury or not the mercury, the pitch and roll cutout switches that will help compensate or not let there be turning errors. They are designed in such a way that they get activated at 10 degrees of bank. तो कभी कुछ एरर हो रहा है एंड 10 डिग्री बैंक है तो इम्पैक्ट हो जाएगा, कट ऑफ स्विचेस कैन वो एरर को रिजॉल्व कर देंगे. इंस्ट्रूमेंट देखने वाले को, पायलट को कोई इश्यू नहीं होने वाला. One point about fast erection system. Generally, erection rate normally gyro or for AH is 4 degrees per minute. No matter where it is, you want to make the vertical come back and stand straight. That's what you mean by getting the rigidity for this. It's a vertical axis gyro. If the gyro is like this, let's say gyro is like this, then you need 90-degree vertical climb. So 4 degrees per minute, 90 divided by 4, that much time it will take if it was completely toppled like this before erection. But my fast erection system, my normal erection rate is 4 degrees per minute. My fast erection system can gives me up to 120 degrees per minute. And how do we do it? It is done by increasing voltage of torque motor. वोल्टेज बढ़ाने से आरपीएम बढ़ेगा, आरपीएम से रिजिडिटी बढ़ेगी, प्लस आरपीएम बढ़ रहा है तो जल्दी रिजिड हो रहा है ना वो, बस. If you have fast erection system, then it gives you an advantage. Okay. What is the advantage? The advantage is that, now tell me, why do you think in the first place I was having a bottom heavy rotor housing? It was required for quick initial erection. Just a while ago, we discussed why it is heavy. A point was mentioned because of initial erection. But that bottom heavy is further causing me errors due to acceleration and turning. So if I have fast erection system and during startup only if I put that into use, then I don't have to design my gyro in a way that the bottom is a little heavy. And if my bottom is not heavy, then turning and acceleration errors will not take place in the first place. So advantage, renders the usage of bottom heavy rotor cage unnecessary for initial quick erection, and thus has no or reduced acceleration and deceleration errors. आप अपने हिसाब से अच्छे से लिखो, मैं डिक्टेट कर रहा हुआ. यहाँ ये डॉक्टर हैंड राइटिंग शायद आपको समझ नहीं आएगा. Any questions? Quick, quick, quick. Time is up. Questions है तो अभी पूछ लो, बाद में सर नहीं मिलेंगे. Quick, quick, quick. What is vertical gyro unit? It is also referred as remote vertical gyro. Also referred as vertically axised data generation unit. vertically, this is the word if you have to use the past present tense for axis. Vertically axised data generation unit. So please don't be a stranger to these terms. Just remember these terms. Keep your life simple. Now, what is the difference? The difference is just this much, that it is the same sensing element of a gyro, but it doesn't give direct indication to the cockpit. But the sensing elements will operate electronic transmission circuits to transmit information to a computer that is called a steering computer. The steering computer here itself could tell you that a computer-based decision-making unit that will tell you to adjust the attitudes of the aircraft, something to do with your autopilot systems on the lines of autopilot. And then from here, they are given to your attitude indicators or flight director systems. Flight director systems are the modified versions of all instruments combined in one, or flight director display systems, we can say. So this gyro gives information to a steering computer that has electrical transmission signals, and then it can go to either this or this, like this. So just a sensor that senses these things, and information is given to certain computers, and from there, the information can be given to us. So most modern aircrafts, you can say, will have these kind of instruments then. So what's your job now? Your job is to be able to read the text and revise. That's it. And be ready for the test. I'm not planning for a live session for now tomorrow because I will be sending a test. अब प्लीज टेस्ट की इतनी भी टेंशन मत लेना कि आप लोग तुक्के मार दो. सोच समझ के आंसर्स मार्क करना है. जो आंसर तुक्के मार रहे हैं वो रिकॉर्डेड होनी चाहिए. सर ये मेरे को आए नहीं है, मैंने तुक्के मारे हैं, बाकी में मेरे को सही गलत है जो देखना है. So probably tomorrow or on the weekend I'll share the test. सरप्राइज आपको भेज दूंगा. परेशान नहीं होना है, बस आप दिमाग में टाइम रख लो टेस्ट का, 5 से 6 के बीच में कल. उस 5 बजे अगर टेस्ट नहीं आ रहा है तो पढ़ लेना आप बैठ के अच्छे से. आपको कभी भी 5 के बाद टेस्ट भेजा जाएगा. आपको जब मिलेगा तब फुर्सत में 1 घंटा निकाल लेना और तब बैठ के टेस्ट दे देना. चीटिंग मत करना, तो आपका भी टाइम वेस्ट नहीं होगा. बट वो दिमाग में रख लो कि कल 5 से 6 मेरा एक ऑनलाइन टेस्ट हो सकता है. 5 से 5:30 होगा शायद, ज्यादा क्वेश्चंस नहीं होंगे, हो भी सकता है. जो भी होगा 1 घंटे से ज्यादा तो नहीं होगा. आपको कंफर्मेशन आ जाएगा. तो कंफर्मेशन नहीं आ रहा, पूछ लो सर टेस्ट भेज रहे होगा, ये पूछ लेना बस. मैं बोलूंगा नहीं, तुम पढ़ते रहो, आएगा तब आपको इन्फॉर्मेशन आ जाएगा. तो आप समझ जाना आपको नहीं आने वाला है 5 बजे मैक्सिमम. ठीक है, फिर कल नहीं आएगा तो कल रात तक आ जाएगा या परसों सुबह आ जाएगा आपके पास. बट वीकेंड पे ही आपको करना है इसका टेस्ट. ये काफी चैलेंजिंग क्वेश्चंस हैं जो एग्जाम्स में आ रहे हैं आजकल काफी, एंड स्टूडेंट्स को नहीं आ रहे आंसर्स, तो हम पहले कवर कर ले रहे हैं सारे. ठीक है, एनी क्वेश्चंस? वी आर डन फॉर द इवनिंग फ्रॉम माय एंड फॉर नाउ. There will be few more points that we might not have discussed. Similar points. Be on the lookout. Add those to your notes. Keep them in your memory. Please read the text once. It will be very beneficial for you because I've taught you directly from there only. So it will be very easy, and when you're mastering textbooks like that, you have nothing to worry about the exams. So do that once and report your doubts over text or your updates whatsoever it is. Okay, students, I think कल आपको टेस्ट आ जाएगा इसके बेसिस पर. 5 बजे, बी रेडी फॉर इट। ओके, रियल टाइम में अगर ना आया तो समझ जाना क्या करना है, बट आ ही जाएगा, आई एम वेरी सर्टेन यू विल गेट इट। सिंपल। ओके स्टूडेंट्स, नो क्वेश्चंस? प्रेरित, गुलशन, करिश्मा, ज्योत्सना, नुकुल, मुस्कान, चैतन्य, थिंक समझ आ गया है? सिर्फ रिवाइज कर लो, याद हो जाएगा। अपना फ्लो चार्ट बना लेना, पैटर्न बना लेना। जो भी डाउट्स रहेंगे तुरंत मेरे को टेक्स्ट करके छोड़ देना। आप लोगों को अच्छे से समझना है, जो मैं इंस्ट्रक्शन दे रहा हूँ वो फॉलो कर लेना। और कुछ कंफ्यूजन होंगी, कुछ भी दिमाग में थॉट आ रहा है, शेयर करो। कितना भी रैंडम होने दो, कितना भी आउट ऑफ द बॉक्स होने दो, कितना भी स्टूपिड लगे आपको, पूछ लेना, क्लैरिफाई कर लेना। लेट्स नॉट जज आवरसेल्व्स। मैं बोलूंगा ना इसकी टेंशन मत लो, बाद में करेंगे। आप बोलना ठीक है सर बता दो ना, मेरे को परेशानी हो रही है। मैं बोलूंगा चलो ठीक है, तुमको थोड़ा बताऊंगा, पूरा नहीं, बट इट शुड नॉट confuse you further. So I would like that kind of learning also, but that should be when you have covered this completely, which is our main task, which in itself is too much in depth, which we are trying to do at a good pace so that we can do everything. This good pace has depth, okay? बिना डेप्थ के आधे घंटे का सेशन है पॉइंट्स बताने का सिर्फ, but it's not possible to do an AH in 2 hours. We have done it. If you want to really get 100%, then go through the task that I've given you. Read it, look for the missing points. Just अंदर के explanation के 4 पैराग्राफ्स आपको skip करने हैं बस। एक पॉइंट है जो मैंने नहीं बोला, मेरा आर्टिफिशियल एयरक्राफ्ट शेप, द गल विंग, इट्स अलाइंड वेयर, विच रिंग, इनर और आउटर, एंड इट्स अलाइंड टू विच इंडिकेशन, ये आपको ढूंढना होगा। ये फर्स्ट इंट्रोडक्शन पैराग्राफ में दिया हुआ है, अच्छे से देखोगे तो। एंड दूसरी चीज जो मैंने आपको नहीं दिखाई है, वो जिम्बल रिंग का कंस्ट्रक्शन नहीं दिखाया। आई डोंट वांट यू टू गेट कंफ्यूज्ड। वो आप टेक्स्ट बुक में देख लेना। ना समझ आए मुझे बता देना। जैसे जैसे आगे बढ़ेंगे लास्ट में आपको शायद दिखा देंगे ऐसा ऐसा जिम्बल सिस्टम है, सो दैट यू डोंट गेट कंफ्यूज्ड। ठीक है, अ वेरी इंपॉर्टेंट इंस्ट्रूमेंट टीसीआई, टीआई बहुत इजी है। डीजीआई एक अच्छे लेवल पे हमने किया है, इफ यू रिमेम्बर। डीजीआई का थोड़ा बहुत और इलेक्ट्रॉनिक सर्किट है, वो थोड़ा बहुत बता देंगे। जायरो इज डन, ऐसे मैं बोल रहा हूँ। तो इंस्ट्रूमेंट्स में जायरो अलग करना है, एयर डेटा इंस्ट्रूमेंट्स अलग करना है, उसमें काफी अच्छे हैं आप लोग। न्यूमेरिकल्स थोड़ा प्रैक्टिस करना, थियोरी रिवाइज कर लो। पीटोस्टैटिक सिस्टम एरर सबसे ज्यादा इंपॉर्टेंट है। क्यूएफई क्यूएनएच बेस्ड क्वेश्चंस जो है ना, वहां पे ट्रिक हो सकता है। CX3 है हमारे पास, मेजरमेंट ऑफ एलिमेंट्स, प्रेशर, टेम्परेचर, ऑल्टीट्यूड, डेंसिटी, ऑल्टीट्यूड, प्ले अराउंड विद दोज थिंग्स, मास्टर इट। क्यूएफई क्यूएनई क्यूएनएच क्या है वो मास्टर करना बहुत जरूरी है। QFE will give you height above the selected datum. आज वो हमें समझ आ रहा है, because the selected datum could be airport elevation if the pressure measured or the reference is ARP, or it could be runway threshold also at times, it could be lower also. So remember that also students now. QFE actually सिर्फ elevation नहीं है, height above the set datum दिखाएगा। And then radio instruments में VOR indicators, half of the questions you will be easily be able to do because you have mastered 1/60. Just instrument देख के समझना है, उसके लिए फुर्सत में हम एक आफ्टरनून सेशन लेंगे बस। उसके बाद न्यूमेरिकल्स होंगे। उसके ग्लाइड स्लोप के इंस्ट्रूमेंट बेस्ड न्यूमेरिकल्स की कंसेप्ट सेम ही है, बस कितने डिग्रीज का डेफिनेशन कितना है। CDI का आपको पता है 1.2 डिग्रीज, 4, 5, 10, 4, 6, 10, और 2.5 फॉर 4 डॉट डिस्प्ले, 2 डिग्री फॉर 5 डॉट डिस्प्ले। तो वहां पे भी कुछ ज्यादा बचा नहीं है करने के लिए, प्रैक्टिस ऑफ कोर्स एंड क्लैरिफिकेशन। रेडार, बेसिक रेडार के लेक्चर आई हैव शेयर्ड विथ यू, डू दैट मच, you have time, so that I can help you with numericals based on radar and a couple of types of radar. वहां पे radar भी हो गया। GPS VPS क्या है, 15 minutes you have to spend। इलेक्ट्रॉनिक फ्लाइट इंस्ट्रूमेंटेशन का भी लेक्चर है आपके पास, तो उसका भी इश्यू नहीं है, वो भी कवर्ड है। यू हैव टू जस्ट गेट डन विद दैट सेशन। वेदर रडार के पैटर्न्स आर आल्सो बीन डिस्कस्ड इन दैट सेम FS का लेक्चर। तो देखा जाए तो कुछ बचा नहीं है, क्योंकि जनरल लैब ऑलरेडी ऑलमोस्ट हो चुका है अच्छे से। स्केल बेस्ड कुछ क्वेश्चंस हो सकते हैं, प्रोजेक्शन बेस्ड कुछ क्वेश्चंस हो सकते हैं जहां आपको कंफ्यूजन हो सकती है, बट वहां पे भी फॉर्मूला है, आपको चेकलिस्ट दिया हुआ है। तो फिर बचा क्या? कुछ नहीं बच रहा है। बट क्या आप इस पेज पे हो? नहीं हो तो आ जाओ बस, और आपको कुछ नहीं करना है। आ रहे हो इस पेस पे कहाँ हो कहाँ नहीं हो, वो सब मुझे बताते रहो, रियल टाइम में चलते रहो, ठीक है? चलो, I'll take your leave, students. Feel free to leave the class. Tomorrow, be ready for the test. 5 o'clock, you should be requesting me for the test. Okay, students? Simple. AH पे टेस्ट होगा, यही सारे पॉइंट्स पे क्वेश्चंस होंगे. Simple. ठीक है? Are we done then? Shall I bow and take your leave, students? Or do you have anything to ask? Only Karishma is saying yes. I think बाकी सब गायब हो चुके हैं क्लास से. ठीक है, चलो Karishma, hats off, and I'll see you. Well done. Immediate answers, quick answers for complicated concepts. Very happy with the progress. And Nukul को छोड़ के अब सब ने भी दे दिया है. So Karishma is the leader in the class today. Keep it up, Karishma. Nukul, I hope you're feeling well. And students, I'll see you tomorrow for regulations and for the NAP test and anything else that you have in between. Just drop me a text. Bye, students. Take care. Enjoy your evening.